We shall now turn to the measurement of spectral reflectance and spectral transmittance with the DTR6 integrating sphere. The first thing we need to do is to move the 45-degree divert mirror to the right-hand side to relay light to the DTR6. We loosen the carrier screw by a quarter of a turn to translate to the right stop, moving the fibre bundle of the bias source where it impedes the movement, and tightening the screw into position. For the measurement of spectral reflectance, we will use as sample the monocrystalline silicon sample, which we have measured in EQE spectral responsivity previously. The DTR6 for the measurement of reflectance should be moved to the right-hand stop. One loosens the carrier of the sphere by a quarter of a turn, pushes to the right-hand stop, and locks in place. In this manner, the beam of the TMC 300 is focused at the plane of the reflectance port. To calibrate the system for the measurement of spectral reflectance, the system is accompanied with a DTR6 reflectance plaque. This plaque has been provided with a cover and has been provided with calibrated data over the range of use of the system. This plaque should be positioned at the reflectance port, holding in place using clips and making sure that the reflectance port is entirely covered with the diffuse reflective white material. We can now move to the software to perform the measurement, noting of course that we have previously connected the sphere detector to the 497 via the bottom of the right hand connections panel ports. We will now turn our attention to the measurement of spectral reflectance and transmittance. Firstly, measuring the reflectance of the monocrystalline silicon cell, which we've previously measured in spectral responsivity and EQE. Running Bemin Plus in the reflectance transmittance mode. Please note that whilst in the spectral responsivity EQE measurement mode, we apply a system calibration through the data correction page. This is not implemented in the measurement of reflectance transmittance. Rather, we use the reference setup page. Here we can load previously measured reference levels for the spectral reflectance, that is a measurement with the DRS reflectance standard in place, and for transmission it is a measurement with no sample in place. For now we are performing the reference measurement for the spectral reflectance measurement, so use reference calculation should be switched off. We will perform a scan over the same range over which we have performed the spectral responsivity measurement, 300 to 1200 nanometers, and hit new scan. At all times, when determining the reference levels, signal in nanoamps should be displayed on the y-axis. We can save this measurement to file in the spectral folder. This is the DRS calibration, and today is the 12th to 2015. I can close that file. And to implement correction, we go to Scan Reference Setup. Firstly, you should load the reference source, which is a spectrum. It is the DRS cal file we've just saved, and the calibrated reference file name has already been loaded here, but is provided in the calibration folder, and is this file here, which relates the calibrated reflectance of this particular standard. We can choose reflectance as the type of measurement and the units, use reference calculation, and hit apply. Returning scan setup, we are now ready to measure the spectral reflectance of our monocrystalline silicon cell. Now we will place our sample to be measured at the plane of the reflectance port. We remove the DRS standard, placing it on its cover for safekeeping, and we can position the monocrystalline silicon cell at the reflectance port of the DTR6. In order to align the monochromatic probe with the sample, we will, in the software, go to a wavelength, a visible wavelength, so we can see the beam, and we can use a port viewer to view what light and where is arriving at the sample plane. To fit the port viewer, we need to remove the specular reflectance cover, translate the sphere somewhat to fit the viewer in place, rotating the position so that one can see the plane of the sample, and push this back towards the right hand stop. By viewing what one sees in the viewer, one can adjust the position of the sample to ensure that the beam falls between the electrodes. And when you're happy with that, you can translate the sphere back, replace the specular reflectance port cover, replace the sphere to the right hand position, and perform the measurement of reflectance. We launch a new scan, seeing on the y-axis the reflectance being reported in units of percent. Now we have reached the end of the scan. We see the reported results for the reflectance of the monocrystalline silicon sample, which we will save in the Bemin Plus Spectra folder, the SI cell reflectance, and we can consider this measurement and the EQE measurement to determine the internal quantum efficiency of this particular device.